Welcome back, folks. Today we are going to be looking at exponential and logarithmic equations and solving those. This is our last day, and the next lesson we should have a quiz for you here. All right. So when it comes to solving exponential and logarithmic equations, and really any equation you ever come across, you can always solve that graphically, right? So you can graph the left-hand side, graph the right-hand side, and find that point of intersection. I actually already have it set up on my calculator here. So there it is, typed in, the left-hand side and the right-hand side, go to graph it, and we see nothing. And that's because the numbers here that we're graphing are very large, right? I can see it's 275 times e to the 0.06x, gonna be a pretty big numbers to start out there. Likewise with 1,000, okay, already very big. So we need to adjust our window. And it's y equals 1,000, so we're gonna adjust the y max. I'm gonna make it at least 1,000, so I'm gonna make it 1,100, okay? We'll graph that. Now I can see the exponential function. Now I can see my constant 1,000, but I can see that they're going to intersect over to the right. So I need to adjust my window one more time, and I'm going to go further right by adjusting my x max to 50. And again, you kind of just have to play around with it a little bit sometimes. If you guess too high, guess too low, you just keep adjusting those x values. I would suggest only adjusting one number at a time, though, to help you kind of keep your bearings. Then we'll go to second trace, go down to intersect, and hit enter, 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 and voila, there's our answer, about 21.516. Okay, which you can see here is what I've got. All right. Now, second method is algebraically. We already learned how to solve one of these kinds of equations before algebraically, of this kind right here, where you can rewrite each one of these bases as a power of 2. 2, 4, and 8 are all powers of 2, right? So 2 to the x stays 2 to the x, 4 becomes 2 squared, and then that 8 becomes 2 to the third. Okay, and we can simplify it, right? So when you divide, you subtract your exponents. So it's going to be x minus 2 in the new exponent there. And then you have a power to a power, so you multiply those powers, and you get 3x in the exponent there. Since you have the same base, and these two things have to be equal, that means the exponents also have to be equal. And so we just drop the bases and just set x minus 2 equal to 3x, and solve for x. You get x equals -1. Okay? So we actually could have done that already. But what happens when we have a situation where we cannot get the same base, like this one right here, okay, where we have, 10 equals 5e to the 4x, right? We cannot rewrite 10 easily as a power of e. What do? Well, we are going to isolate the exponential part. That's the base in the exponent. So in this case, that is the e to the 4x. We're going to isolate that, and that's going to happen by eliminating the 5. To eliminate the 5, we will divide both sides by 5. 10 divided by 5 gives us the 2 here. 5 divided by 5 cancels, and you're left with just e to the 4x. Now at this point, we have isolated the exponential part, and now we're going to use a logarithm. Okay, we actually have two options here. I'm going to show you the more intuitive way maybe for you, and that would be to use the logarithm that has the same base as your exponential here. So in other words, what logarithm has a base e? Well, it's the natural logarithm. So we're going to use natural logarithm on both sides. ln of 2 equals ln e to the 4x. The properties here for the natural log of e to the 4x, right? The ln and e will cancel. You'll have just the 4x there. And then you have ln2. To finish solving, you just divide both sides by 4, and you get this answer right here, okay? You can also rewrite that as 1/4 ln2, or you can rewrite that as natural log 2 to the 1/4, right? You can bring that exponent up into the power, or bring that coefficient up into the exponent there of your logarithm. Either way, you can go ahead and easily type those in your calculator, and you get 0.173. But I told you there was a second way. You don't need to match your log's base with the base of the exponential. So for example, looking over here, okay, you can see that I'm just going to start from this step right here and go to here. So we start with a 2e to the 4x. I need to eliminate that base e to get that 4x out of the exponent. How do we do it? Logarithm, but it can be any logarithm. I just randomly chose log base 3 here to do on both sides. Now when I do log base 3 of 2, it does not simplify, so it stays log base 3 of 2. Okay, when I use this though, I can bring that 2x out front. Again, it's an exponent, so I logarithm properties, I can bring that out front of the exponent. I'm sorry, out front of the logarithm, so I have 2x times log base 3 of e. And then I can divide both sides by log base 3 of e like you see right here to cancel out and get that x by itself. And then furthermore, 2x, this should be a 4x. And then I'll cancel out the 4 by multiplying both sides by 1/4, and so we will have x is equal to exactly log base 3 of 2 over 4 times the log base 3 of e. To evaluate that in our calculator, well, you have some options. Okay, to go to our home screen, Go to home screen, you can see I already have typed in. To do a log, and I'll go ahead and hit enter, you can see, boom, there's the same decimal point that we got from before, right? Okay. What you can also do here, though, actually, I don't know if I did it before. Anyway, that's our decimal point, 0.173. To do this, if you have a newer calculator, if you press the math button, and you'll be able to tell really quickly, if you press the math button, and if you arrow down, you see log base. Log base allows you to type in a base number and the number inside the logarithm there really easily. So I can easily do, bases of other logarithms there. What happens, though, if you have an older calculator that doesn't have that log base command? Well, then you can either use the log button, which really remember is the log base 10, excuse me, or you can use the natural log button, which remember is log base e. Either one will give you the same answer here. What you'll do then to evaluate, for example, that log base 3 of 2, you'll do log of 2 divided by log of 3. So log of the big number divided by log of the little number, and you can see you get the exact same decimal. Likewise, if you use natural log of 2 over natural log of 3, you get the same decimal, okay? So you can use those to help you evaluate logarithms that you otherwise wouldn't be able to do on your calculator. All right, moving on here. Let's continue solving. So, again, here I'll just kind of go through. So we'll add 4 to both sides, right? We get 5 to the x equals 11. For this one, I will match the base, so I will use log base 5 of 5 to the x equals log base 5 of 11. These will cancel, all this is just x, and so x is exactly log base 5 of 11. Then you go to your graphing calculators. I'm just going to type this one in. So actually, I'll do it real fast. So log base 5 of 11. So I'll do it like I have a calculator that doesn't have that log base command. So log 11 divided by log 5. Again, it's the big number divided by log of the big number divided by log of the base. And we get 1.489, which is around to 1.490. Okay. And there's our answer. Again, I want the precise and the decimal. You should be able to give me both, okay? It's going to be super important for those you moving on to calculus that you can get precise answers and decimal answers like that. All right, subtract 5 on both sides here. Cancel the 5s out. 2e to the x minus 1 equals 75. Divide both sides by 2. Again, we're isolating this e to the minus 1 is our goal here, so that cancels. We have e to the x minus 1 equals, and 75 divided by 2 is 37.5. Okay, and then we will take the natural log of both sides or use some other base. So, I'm just going to use natural log here again. I'm going to match up the bases. I think that's just easier to do. Okay, so you get x minus 1 equals, and then whatever the natural log of 37.5 is. Okay, you notice I'm not simplifying that natural log of 37.5. I'm not making that a decimal yet. I'm leaving it precise. I'll add 1 to both sides, and so I get the natural log of 37.5 plus 1, okay? That is the precise answer, and then if I type it in my calculator, I'm just going to do this on my calculator here in my hand, okay? The plus 1's on the outside of the logarithm, so make sure you close the parentheses around that 37.5, and you should get about 4.624, okay? All right, let's keep going here. Word problem. Suppose $250 is deposited in an account that pays 4.5% interest, compounded quarterly. How long will it take for the account to double its original value? Okay, so that's going to be our compound interest formula. A equals P times 1 plus R over N to the NT. And we'll just plug in our information. So there's P. Okay, let's see here. 1 plus R is 4.5%, but you have to write that as a decimal number, so it's 0.045 over N. Number of times compounded is quarterly. Quarterly, there's 4 quarters. And then N is 4 again, and then T is the variable we're solving for. So what's A then? Well, double its original value is what our final amount is going to be, so double 250 is 500. Okay, and we'll go about solving this. So again, we want to get that. We want to solve for t, so I have to isolate this exponential stuff right here. So let's simplify. We'll divide both sides by 250 first. So you get 2 equals. I'll go ahead and add this stuff together here too. So 1 plus 0.045 divided by 4. Okay, and I'm not going to round this. Don't round this. So you get 1.01125 to the 4t. Okay, and you can go ahead and do log base 1.01125 if you want. Again, our exponential is isolated here, so we're going to use a logarithm. So I'll do log base 1.0112. Actually, you know what? I'll use natural log for this one just to kind of change it up. Okay, so I can bring that 4t out front here. Like so, and I'll divide both sides by 4 and the natural log of 1.01125. I'll just do it like this, okay, like that. Whole thing's being divided by that, right? And so then I get t is precisely the natural log of 2 divided by 4 times the natural log of 1.01125. When you type this in your calculator, please make sure you put parentheses around the denominator, otherwise it will not evaluate it correctly. Natural log of 2 divided by parentheses 4, natural log of 1.01125. And I get approximately 15.49 years. Okay, you have to kind of look into the context of the problem if you want to give you like a whole number of years. I mean, technically, 16 whole number of years, right, is what's going to take. 15 years won't quite make it, right? So you can do a little bit further. All right. Solving logarithmic equations. So here's that. And I know I'm already at 10 minutes, but I'll promise this will go quickly here. So solving a logarithmic equation, you want to isolate the log and then use exponentials to cancel it out. Here we can see that we have logs on both sides of the equation, but they're isolated, right? This log is by itself, this log is by itself. How do we cancel it out? Well, remember that the base of this logarithm, when there's no base written, that we understand the base is 10. And so what do we use? We do 10 to the left-hand side here, and we do 10 to the right-hand side here. Okay, 10 will cancel out that logarithm, just leaving you with a 5x. 10 to the log of 2x plus 9 is going to be just 2x plus 9. Wow, how easy is that? Subtract 2x on both sides, we get 3x. Divide both sides by 3, we get x equals 3. Okay, now here you really should check these things back in your calculator, or at least plug them back in, because remember that logarithms have a limited domain, right? You can't take the log of a negative number, for example, so you want to make sure that you don't have any extraneous solutions. If I plug that back in, it's going to be 5 times 3, so 15. If I plug it back in on the right-hand side, it's going to be 2 times 3, 6 plus 9 is, again, 15, so check, it works. Oops, I almost X'd it out, like it was some sort of wrong answer. Why would I do that? Okay, check. It works. Okay, anyway, let's try another one. All right, next example. Here we have a logarithm, but the logarithm is not isolated. We have this negative 6 we must deal with. So we'll divide both sides by negative 6. And we get log base 3 of x minus 3 equals negative 24 divided by negative 6 is 4. Now, we've isolated the logarithm, right? That x minus 3 is inside the log, so we can't do anything with that just yet, but we can use an exponential. We'll do 3 to the left-hand side and 3 to the right-hand side. That'll cancel out the logarithm there, leaving x minus 3. 3 to the 4, well, 3 times 3 is 9, and then times 3 is 27, times 3 is 81. And then we'll just add 3 both sides, and we get 84. Again, if you were to plug it back in, you'd get the same thing. And again, you can check into your calculator and stuff like that, okay? But 84 will work there. All right, next one. All right, logarithms on both sides. It's a natural log. What's the base of a natural logarithm? Remember, it is a base e, right? Okay, so we're going to use e to the left-hand side, e to the right-hand side, since they're already isolated. It's going to cancel out. We'll have n squared plus 12 equals negative 9n minus 2. And oh no, it's a quadratic. I mean, oh yay, it's a quadratic. So we will get everything to one side. Let's see if this thing factors. Let's see, 14 multiplies to 14, adds to 9. That's got to be 7 and 2. So n equals negative 7 when you solve, and n equals negative 2 when you solve. Now, here's the tricky part, right? We want to make sure that we plug this back in, that both of these will be right. So let's see here. If I plug in negative 7, I'll get 49 plus 12. And if I plug in negative 7 here, I'll get, let's see here, negative 7 times negative 9 is positive 63 minus 2. Will those be the same? Yes, they will, right? This will be the natural log of 61. This will be the natural log of 61 as well. So check, that one works. Let's try negative 2. Okay, so negative 2 squared is 4 plus 12 is 16. So the natural log of 16 equals natural log, let's see here, negative 2 times negative 9 is negative, or positive 18. 18 minus 2 is 16. So, check, that one works too. All right, so they both work. That's good. Last one here, I think. Yes, congratulations, we're almost done. Last one here, we have two logarithms and they're on the same side. What do we do? Well, we could try subtracting one over, but then it'll be like 1 minus the log base 8 of 2. We can subtract the 1 over, but then it'll be with that logarithm. So we're going to be kind of in some trouble there if we try and isolate these logarithms on either side. What we can do, though, is, well, we're adding two logarithms together, right? And they have the same base. How can we combine two logarithms that we're adding together and they have the same base? They multiply. Remember, that's one of our properties of logarithms yesterday. So we can do 2 times 4x squared. Actually, I'm just going to write it this way. Like so. Equals 1. Okay, that really simplifies to 8x squared then, right? And now I have my logarithm isolated. I'll do 8, because my logarithm is base 8, so I'll do 8 to the left-hand side and 8 to the right-hand side. Those cancel. I have 8x squared equals 8. Divide both sides by 8, x squared equals 1, and then square root both sides, x equals 1. Plus or minus 1, don't forget, okay? And then both of these will work back in the original because you're going to be squaring those. You're going to end up with the same result either way, okay? So both answers do work there. All right, thanks guys for sticking with me. I'll give you a few problems for homework, yeah, hopefully it goes okay. Quiz next lesson. Bye.